Assalamualaikum and good morning to our panelists and our viewers. For the FYP presentation, I will present my research, which is the comparative study of the Pico-Hydro system via CFD analysis. My name is Muhammad Amiruddin bin Sharif and my supervisor is IRTS Dr. Muhammad Azim bin Mat Yusof. As for introduction, Pico-Hydro system is like a smaller scale of the hydroelectric dam. Its function is to generate electricity by using the energy of the flowing water to spin the turbine, thus generate electricity without depend on any non-renewable energy source. There are various types of small hydropower generator that exist. It consists of small, mini, micro, and pico. As the size of the hydropower generator is different, so does the power output. Based on the table, we can see that the power generated for each category. As for the small, it is capable of generate 1 to 10 megawatt. For the mini, it's capable to generate 100 kilowatt to 1 megawatt. For the micro, it's capable to generate 5 kilowatt to 100 kilowatt. Lastly, the Pico is able to generate the power below 5 kilowatt. For your information, Pico-Hydro is used in an off-grid or isolated area that have difficulty to access electricity. Therefore, this research is focused on the Pico-Hydro category because its system is applicable to the household water pipeline and the small consumer. For the problem statement, the main issue that we found during the research is that the power generated by the Pico-Hydro system is small and the energy can be used only for a short time. This is happened due to the energy losses during the energy transformation process, which is the kinetic energy to mechanical energy into the electric energy. The other variable that factors also is the water usage during the peak hours that can also affect the flow rate of the water in the water pipeline. Hence, the modification can be done onto the existing system so that it can harness the energy of the flowing water more efficiently. The objective of our study is to implement the different parts that is recommended for the Pico-Hydro system. Then we can compare the performance of the new Pico-Hydro system with the previous design via CFD analysis. Then based on the produced result, we can study the effect of the Pelton turbine on the new system. During the literature review, we found that the Pelton turbine is the recommended parts for the Pico-Hydro system. This is because it is widely used in the Pico-Hydro. Furthermore, it is compatible with the high head or medium head pressure and low flow, such as the household situation or rural area. In addition, it is easy to fabricate and economical because the material that was used to fabricate it is PVC, which is cheap, and the skill required to manufacture it is low. Then the implemented nozzle on the previous design able to increase the turbine speed because the Pelton turbine is depends on the pressure of the water. With the increase of the rotational speed of the turbine, the power output of the Pico-Hydro system also increase because the power is depends on the torque and the rotational velocity of the turbine. The process of the study is start by doing the literature review. In the literature review, we found the issue that is related into the Pico-Hydro system. Then we can determine the objective and the scope of the study. With the objective determined, we can gather the information that help us improve the Pico-Hydro system, which is Pelton turbine. Next, we can start the modeling stage, which is creating the 3D model of the Pico-Hydro system. In this stage, we create two 3D model, which is Pico-Hydro system that use the Pelton turbine and the cross flow turbine. Then we can start doing the simulation by using the CFD software. In this simulation, we use the ANSYS Student to simulate both of the 3D model. Then the performance of the Pico-Hydro system can be determined by varying the flow rate of the water used. Then from the simulation, Then we can produce the result and the conclusion, which is the end of this study. In the modeling stage, the CAD software that we use for modeling the Pico-Hydro system is SolidWorks. And as you can see, this is the model of the Pico-Hydro system. In the simulation stage, the boundary condition that was set in the simulation is shown as below. The simulation type is set as the steady state. The turbulence model is K omega because it is more suitable for the near wall flow, and the fluid that was used is water to simulate the flow in the household pipeline, and the inlet for the Pico-Hydro is of course the flow rate, and the outlet is the total pressure. So from the simulation, the input and the output for the simulation is the flow rate, and the output will be going to be the rotational speed and the torque that was produced by the turbine. By using the formula P equals to torque omega, we can calculate the power generated by the Pico-Hydro system. This is the expected result for this study. For your information, the result is obtained from the previous research paper because the simulation of this study is still in trial. Therefore, you can see the flow rate that was being used for both models is different. As you can see, the result from Pelton turbine, the turbine velocity and the output power is higher than the cross flow turbine. In the Pelton turbine, the highest velocity produced is 1200 rpm, and the highest output generated is 42.69 watt. In the cross flow turbine, it produces 365 rpm, and the highest power generated is 1.159. Therefore, we can see that the Pelton turbine gave highest output power and turbine velocity than the cross-flow turbine. This is the graph of the power versus flow rate for both models. As you can see, the performance of the model A is higher than the performance of the model B. This is because the rotational speed is directly proportional to the power. As you can see, there is a huge gap of the performance between the model A and model B. This is happened due to the different scale of the Pico-Hydro system that was being used and the different method of the implementation that was happened during the previous research. In general, we managed to obtain the plausible result for this study. The result obtained for this study is considered to be a bit inaccurate and unsatisfying. This is due to the limitation of the CFD software that we use, which is ANSYS Student version. The version has limitations which make us unable to run the simulation for our model. Furthermore, the previous research has done a different methodology, therefore produce a different result, which make us have a inaccurate result. In addition, the lack of my knowledge in using the CFD software also affect the outcome of this study. As you can see in the picture, we are unable to get the amount of the rotational speed for the turbine in the simulation. Therefore, the simulation of the CFD in this study is still in trial. However, we can conclude from the result that the Pelton turbine probably able to improve the performance of the Pico-Hydro system. That's all from me for my final year project presentation. Thanks to the panel and our viewers for lending me your time and ears.